Hello friends, in this video we are going to see about the data types in Java. So there are two types of data types in Java. First one is primitive and the second one is reference data type. In primitive data type, using primitive we can represent the numbers, characters, decimal numbers and boolean values. So let us see the types. First one is integer. In this, you can store a whole number. In the sense, you can't store 5.5 are the decimal values in data type. We will see practical implementation, but here we are just taking an overview of all the data types. You can store 5, 10, 15, but you can't store the 5.5 value. Second one is the long. Now, long is the extended version of integer. In integer, you can store only 32-bit signed values, whereas in long you can store 64-bit. So it is an extended version. If you are working with the larger values, then you can use the long. Now, what happens? The example here you can see the example 15 and L. We have written here L as a suffix to represent that this is a long number. If you don't write here the L, then this will be considered as by default the integer variable. So to differentiate, we have given a suffix L. The next one is Boolean data type. In Boolean data type, you can store only two values, true or false. After that comes the character. You can say the character will be represented by single quotes and you can store only single characters like A, B, C and all that. Then comes the float. In that you can store the decimal values. In float also, you can see here we have mentioned a suffix called f. Now if you don't mention this suffix f, then it will be considered, this number will be by default considered as double. Now the difference between float and double is same as integer and log. This is 32-bit decimal number and this is 64-bit. Now if you are here, if you don't mention f, then this will be considered as double and it will take up to 64-bit space. So whatever your need is in the program, according to that you can declare this float or double, or in this case also integer or log. Now let us see the next type of data type, that is reference data type. As the name suggests, the reference data type is used to store reference to the object rather than the actual value of the object. Now what is an object, what is in class, all this we will discuss in the next video. Here we will see this, just think object as an variable only, like the primitive one, but it has different, we can't say that it is a primitive data type, but you consider that something is stored in that object, like some values and all that. We'll discuss what objects are in the next video only. So what happens that whenever you declare any reference data type, it stores the, uh, first of all, in that reference data type, the values are stored and the value is stored in a memory, now at a particular memory address. So the reference to that address is stored in this reference data type. Now let us see the examples of reference data type. And that first one is string. String is a sequence of characters. In primitive data type, we have seen the characters. So characters are represented by single quotes, whereas string is represented by double quotes, so that you can differentiate between them. And the next thing is that in that character data type you can only store single values, whereas in string you can store a sequence of values, like you can store full name or whatever you want. You can even store paragraphs, sentences, whatever you want. The second one is array. Now array is collection of similar data type. In the primitive data type, you declare int a equal to 5. Now in that only you can store one value. So if I want to store more than one value in one variable, then you can use arrays. While declaring this array, you need to give a fixed size. Consider you want to store 5 elements of similar data type, let us say integer data type. So to store that 5 elements, you need to give the value 5, that I want an array of 5. Now what happens that the array of 5 is declared in the memory in the continuous form, and in that all these values will be stored. Now the reference to the first value is stored in this array variable, and the last one comes the object. In the object we store the instance of the class. So this we will cover in the next video, as I have said. Now let us see the practical implementation of all these data types. Here in this class, I have tried to implement all the primitive and non-primitive, sorry, reference data types that we have learned in theory section. So here I have created a package inside this Java. In the IntelliJ you have this structure inside the source, inside the main, inside the Java. We need to write all the Java classes and packages. So inside that I have created a data type package, that we have a class called Java data types. Now don't worry about what is class and objects. We will see about the classes and objects in the next video, so you can refer that and understand what are classes and objects. For this you just create a class and try this program. Just create a class uh, by right click on the project and new, and here you can create a Java class, package, whatever you want. So create just a Java class, give this name, and create a main method here. As we know that the execution starts from the main method. So let us see primitive data type. The first primitive data type is boolean. I have already written all the things because so that we can understand all the concepts clearly. So here first I have written a first we'll see the boolean data type. A boolean data type has only true or false value. It can store only true or false. So this is a south line. This will simply print whatever is present in between the double quotes in the console. Now let us write boolean data type. In that we need to give the boolean variable name. So value, let us give the name value equal to true. Let us say true and semicolon. Now you have assigned true value to this boolean variable. So let us see, let us print this. So in IntelliJ we have shortcut s out. So you will get a println statement, and here you can print the value of this boolean variable. Now save this program and just run this program. Okay, you can see here it will take some time for first when you run the program first time. After opening the IntelliJ. So don't see all these things. First we have only created the boolean variable. So you can see boolean data type and we got the value true. If you give here false, the output will be false here. Okay, you can see here we got the output false. Now let us move on to the int data type. Now int data type is 32-bit signed integer. That means you can store negative and positive numbers. Now here we can store the numbers in the range of range given here. This many negative numbers and this many positive numbers you can save in the you can store in the int data type. So let us create a int data type and let us say positive, sorry, let us say number equal to, let us store negative value -5 and print it, sorry, number. Now you can see we got -5 in the output. Now let us try to exceed this value. That means the range is still, you need to remove the commas. So this is the range of in data type for negative numbers. So 648. So we will do that 649 and see what error we will get. So you can see we got an error here. Integer number is too large. That means it is exceeding the value of the range. So that gave us an error. You can print this value, but 648. Here you can see we got this number. Now the next data type is long data type. In long data type, it is the extended version of this int data type only, but 64-bit, we get 64-bit, whereas here we got only 32-bit signed integer. So you can see as we get 64 bits, the range is increased. We got more range than that of this integer number. So if you are working with a program where we need a large whole number, then you can go with this long data type. Now one thing you need to remember is that after writing the number in the long, you just need to give the suffix l so that you can differentiate both this number. Now if you don't give the l here, it will by default consider the integer number. Let us see that long x equal to, sorry, long number equal to, let us give 25, positive 25 and l. Print the log number. Now let us try that you can print a value greater than this. No, we have seen the negative number, so let us print this value here. So we are clear, we can get an idea that if we are working with larger numbers, we can use the long data type. You can see here if we write 9 here, so if you don't write l, it has considered this as integer number even though we have declared here long. So you can see integer number too large. Now if I just write l here, the error is gone. So what happened that you always need to write l after the long number to
to specify that this is a long number. Now let us save this and run the program. This number we are not able to print in data type. Now you can print in long. So you can see here 49, we can print 49, and here we can only print till 48. Now next one is the float data type. In the integer and long, you can only store the whole number and you cannot store the decimal values. You can see here if I write 0.5, we'll get an error. So to store the decimal numbers, we can use float or double. Now the it is a 32-bit decimal number and the range is between, for negative numbers this, and to positive number this is the range. In float data type, you need to give suffix f as we have given in the long data type. So let us see an example. Float number equal to 25.6345. Now see, we got an error here. Here it says that required type is float and you are providing double. So what happens that if a decimal numbers, you are assigning a decimal number to a float data type and not writing the suffix f, then it will be considered as double and we will get this error. So if you write f after this uh, decimal number, you can see the error is gone. Now let us just print the float number, save this program, and let us see the output of this float number. You can see the float data type and the output is 25.6345. Now same, let us close this. Now same, we have double data type. It will also store the decimal number only. This will also store the decimal number, but it is 64-bit. So same as long and integer, difference between float and double is same. So here the range is lower, and as it goes to 64-bit, the range increases. So whenever you want to work with larger decimal numbers, you can go with double data type. Here let us write double, and double number equal to 8500,369.256345. Let us take a random number, and you can see that we can print this, we can store this value in this variable of double data type. So you don't need to give any suffix in the double data type. uh, the decimal numbers are by default considered as double data type, but if you want it to be considered as float, you need to give f as suffix. Now let us print this value, double number, save this program and run. So you can see I got the output here of double data type. Now the last data type in the primitive is character. In the character you can store single characters. So let us see this by example. To store the character values, you need to write char and character equal to. Now character values are stored in single quotes. That means whatever you want to assign the value to this character data type, you, all that values you need to give in single quote. Now here in character you can only assign a single character like a. You can't write ab. See, we got an error here. If we write too many characters in character literal, so you just need to give a single character to a single variable of character data type. Here the a is stored in this variable. Now let us print that character, sorry, capital character. So save this program and run. Okay, sorry, I have copied this, so we got an character data type. Save this and run the program again. I have copied this template, so we got the output as double data type 2 times. So here you can see character data type, and we got the character that we stored in this variable. Now all the primitive data types we have covered: boolean, integer, long, float, double, and character. Next we'll move on to the reference data type. Now next one is the reference data type. As we have discussed, in reference data type, the reference to the value is stored, not the original value. Original value in the sense the value that we have assigned to the variable. Now in the reference data type, we will see two of them: string and arrays. Objects are we will cover the objects in the next video. So first let us see what is string. String is a sequence of characters. There are two ways to create string variables. Okay, we'll see that. So what happens that in character data type of primitive one, we can only store this single character. Now I want to store my name, then we can use this string data type. So the first way to create the string is write string with capital S, give the name of the variable, let us say str. You can give the name of variable whatever you want. So I have given here str equal to. Now we write the character variables in single quotes. Here the string variables are stored with we need to assign that by double quotes. So you can see we can even assign the empty string to this string data type. Now here I am writing Ramesh, random name. So you can see that this Ramesh is stored in this string variable, and let us just print the name Ramesh str. Save this program and run. You can see here we got the string Ramesh. Now the second way to create a string is that this directly is we can create this string directly. Now second way is to create using new. That is similar to how we create the objects. New string, new, sorry, let us give new str equal to new string. You can see here, and the value that you have given here as Ramesh, you can here in this declaration we need to pass inside this brackets. So let us say Suresh, the brother of Ramesh, let us assume. And what happens here, thus this string is stored in the string pool, whereas here every time we will create a new object and it is stored in the heap memory. All this what is heap memory and string pool, we will create a video, separate video on string and arrays, because it is a these topics are important and we have many things to discuss in this. So a detailed video will be created on strings and arrays also, but as of now you can say that every time we create using new, it will get a new memory address. And if you create a variable in this, then this will be uh, stored in a pool where if the similar value is declared in the program again, then it can be shared from that string pool. Okay, so let us print the second value, the Suresh new str. Save this and let us run the program. Now you can see we got Ramesh and Suresh, both the brothers are together now. So we have declared the string and we have printed that. Now the last one is the arrays. Now arrays are the collection of similar data types. What happened that the problem before was that we can only store one value in a data type, primitive data type. Let us say integer, I can store only one value, but I want to store more than one values, then for single variable and assign that in a single variable. At the time you can use the arrays. To solve this problem we can use the array, and the declaration of array is like you need to write which data type of which data type we need to create array of. So I want to create a array of integer, so I have written here int data type, and you need to give a bracket, square bracket here. This is a declaration syntax, you need to write this. This describes here the dimension. We are creating 1D array, so it has only one row. Now give the name of array, let us just write the array equal to, here we need to write new because this is a reference data type and integer. Here in this square bracket you need to give the dimensions, like how many elements you need to store. So I want to store only 3 elements, so it will create an array in the memory, a continuous block of memory with three, already three memory address assigned and given to us to store the values. Now to store the values in this array we can use the index, like array at 0. Now indexes are always start from 0, so 0, 1 and 2. Three values means 0, 1 and 2. Let me write that. Index starts with 0. So for 3 we need to have 0, 1 and 2. We'll give 5 for 0 index. For 1 index you need to give whatever value you want to assign, you can assign 18. I'm taking here the random values. And the third one is, let us say 50. Okay, now here I have declared 3. That doesn't mean that I need to go till 3. This is the count. You can store 3 variables. Now if we start from 0, 0, 1 and 2, so you can see we have stored the 3 variables in this array. Sorry, 3 values in this array, not variable, sorry. So the index will go till n minus 1, 3 minus 1, 2 only. Now to print this array we will use the for loop. A for loop we have seen that in C language also. So I assume that whoever is seeing this video is has a basic knowledge of for loop and cleared some of the basic concepts from C language. So here we need to start I from 0 and we need to go to array less than array dot length. Now array dot length is, we get the value 3 here and the loop will go till the less than array dot length. That means 3 less than 3 is 2. So 0, 1 and 2 will be printed. And I plus plus, you know that it is an increment operator. So here let us write s out. Now to access, to store the element also, we to store and access both we will use the index. So here you can see to store the elements we have used the index. Now to access the element also we will use the index only. So here we will write I because I will iterate from 0 to 2, and every time here the value will be changed and the respective values present inside the array at the given index will be printed here. So let us save this program and run. So you can see in this array data type we got the values 5, 18 and 50. Now there is another way also to declare this array. So you write integer, similar, you give the square brackets. Remember that you need to always give the square brackets because this is the syntax. As I have said, this is a 1D array. You need to mention the one dimension here and how many values you are going to store in that. You need to mention on the other side, on the right side. So similarly, here you need to give this square brackets arrays. Let us give the name as arrays. You need to follow proper convention, but here for example I am taking the name as arrays and equal to, in the curly brackets you can give 10 comma 25 comma 65. Now in this way also you can create an array. Here what you are doing is that in this first type of declaration, what we have done, first we have declared an array, assigned this continuous block of memory for 3 values, then we have stored the value, then we have assigned the values. Instead of that, what we have done that we have declared an array and assigned the values here only. Now what happens here is that 10, 25 and 65 is stored in the arrays, and you can't now increase the size of the array. This is fixed. Yes, you can here write more elements like 56 hours. One more element you can write 80. So what happens is that the we will get a array with the length of 1 2 3 4 5 5, and that is this all these values are stored in this array. And let us try to print. So we need to use the for I equal to 0. So we need to go to the till arrays dot length less than arrays dot length, because the value stored in the arrays will always be less than 1 less than the length. You can see here 3 minus 2, 3 minus 1, 2. So we'll go till the array of length and print all the values that are less than the array. Now just write s out. To access the elements in array, we need to use the uh, arrays index. So arrays, in the square bracket, you need to mention which index you want to print. So we want to print all the values. So we'll write here I, and you can see from 0 to till length it will go and print all the values present in this array. Save this program and run. Okay, so we got here, we mixed up these values. So let me just write a print statement here so we can differentiate both this. arrays. Okay, save this program and run. Now you can see we got this line breaker here, and you can see 10, 25, 65, 56, and 80. All the elements that we have assigned to the second array is printed here. So these are the way, both ways by that you can declare the array and initialize it. Now we have completed all the primitive and reference data type here. If you have any doubts, questions, or any problem in this program, you can write that in the comment section, and I will respond that question as soon as possible. And one more thing, I will add this code in my GitHub, so you can access that, and the link to that GitHub repository will be given in the description section, so you can refer that also.